All right, we're going to continue on our work with linear functions, and in this video we will be looking at standard form, which is our third form of a linear function, and we'll do an introduction and some examples. So standard form is this right here, ax plus by equals c, and we want a, b, and c generally to be integers, to be whole numbers. So if you end up with a fraction in standard form, we can multiply the entire equation through by the denominator to force a, b, and c to be whole numbers. Sometimes people like to avoid having a be a negative. It doesn't really matter too much, but that might be something you'll come across sometimes. And obviously x and y are the two variables we're working with. Okay, all of these different forms we're looking at have their advantages and disadvantages. I think standard form is most advantageous for word problems. Okay, and in our real world connection problem, I think we'll get to an example like that. It makes it really easy to write out a word problem. If you buy this many hamburgers and this many hot dogs and spend this much money, it's pretty easy to write out a word problem where x might represent the cost or maybe the number of the hamburgers or hot dogs, and then y might represent the other. So that's one of the real benefits of standard form. Standard form in some cases is easier to graph, and I'll show you that with our first example, but it's not necessarily always easier to graph. I honestly think that slope-intercept form is the easiest to graph. But let's do that example in terms of graphing right now. So graphing using x and y intercepts. So we want to graph the following function. And so the function is 2x minus 3y equals 6. Okay, so you might be tempted, if you're not familiar with standard form, to do a lot of algebra and get this into slope-intercept form and then go ahead and graph it. But there's a clever way that you can graph this guy without doing all that algebra. It's called using the x and y intercepts. And so let's pretend, first we're going to pretend that x is 0, and we're going to try to figure out what y is. And then we're going to pretend that y is 0, and we're going to try to figure out what x would be. On an actual piece of paper, I use my thumb to cover up the x term. When I'm solving for this y value right here, x is 0, I sort of use my thumb to cover up that x term right there. And then it's easy right there to see that negative 3y is 6. If x is 0, right, the x part goes away. So negative 3y is 6, and so y is negative 2. All right. And similarly, let me see if I can erase what I just did, covering that up. Cool. Okay, so similarly, if y is 0, that means that all of this y stuff disappears. We have 2x is equal to 6, which means x is just 3. So let's see what we just did. We have two easy points to plot. They're intercepts because one of the coordinates is 0. So our y-intercept is 0, negative 2. Let me get that axis back. Okay, our y-intercept is 0, negative 2. And our x-intercept is 3, 0. Okay, remember this is our x-axis right here. Our x-axis right here. And our y-coordinate is 0 on the x-axis. Okay? And once we have 2 points plotted, we can pull out our ruler, connect them with a straight line. Let's see if I can get that. Super. And there's our line. We graphed it up. One of the drawbacks of standard form is it's not clear right away from the equation what either the slope or the y-intercept is. Okay, so that's definitely a drawback. It does look like our slope, however, is up to over 3. So slope is related to, I'm not going to formalize this rule right now, but slope is related to these two values right there. Okay? And it looks like our y-intercept is negative 2. Okay, so you can get that after graphing it. It's pretty straightforward, but it's not immediately obvious from the equation. All right, let's look at some special cases here. And sometimes either a will be 0 or b will be 0 in the equation. Okay, so it's not just we're plugging in 0 for x or y and these terms disappear. They're just already 0 in the equation. So same idea here. For this first one, 0x plus 3y is 5. Really, that's our equation right there. 3y is 5. I think it's easiest just to turn this into slope-intercept form, and we get y equals 5/3. Okay? And so the slope is 0, right? Y equals 0x plus 5/3. So y equals 5/3. That's 1 2/3. So that's about right there on my axis, and we can just draw a line right there. Okay, so this equation has that line right there. It's just a flat line with a slope of 0. Similarly, when the 0 term is paired with the y in the equation, essentially this we don't even need to worry about this. We have a negative 2x equals 4 divided by negative 2, so x is negative 2. Okay, so it's going to be this equation right, this line right here going through negative 2 on the x-axis. So this equation is going to have that line right there. Okay, so if we have a special case, either a or 0 or b is 0, we'll get either a horizontal or a vertical line. Okay, hopefully you're realizing that vertical line is not a function because there are multiple y values for the same x value. It's a vertical line with an undefined slope. Last one we'll do in this video is getting a function into standard form, and I alluded to earlier an important piece of this is making sure our a, b, and c values for standard form, which I'll remind you of right here, those we want them to all be integers, okay? That's what makes standard form in part a little friendlier. We have just integers we're dealing with in the equation. So honestly, what I'll do first is just multiply through by whatever denominators I see. So for this left-hand one, I just want to multiply the entire thing by 5, okay? So I'm going to get 5y equals 4x minus 35. This, hopefully you're seeing this 5 and this 5 cancel, okay? And we can subtract 4x from both sides. And we get a negative 4x plus 5y equals negative 35. That's a good place to stop right there, although some people like having the first term be positive. It's really how picky you want to be. It doesn't really matter, but we can do that. Not too hard. We can multiply both sides by negative 1. Okay, so that's going to turn, that negative 1 will distribute all the way through. Basically all the signs change. So that's a reasonable answer as well. Okay, so both of these would be correct answers. All right, and so that was going from slope-intercept to standard form, and now let's do one from point-slope form to standard form. Okay, and what I'm going to do first here is just distribute my 5 through, and I'm going to get y plus 1 equals 5x minus 10. And let's subtract 5x from both sides because we want all the variable pieces on the left. And let's see what that turns into. We get a negative 5x plus y plus 1 is negative 10. And we can subtract 1 from both sides as our final step. And we have a negative 5x plus y equals negative 11. And then same deal for that other example I just did on the left side. If we want our initial coefficient to be positive, we can just multiply through by negative 1, which acts to flip all the signs. And either of these would be legitimate final answers. And that's a good place to stop right there.